right, here we go. New chapter, new packet, chapter 8 on chemical reactions. And this first video, we're going to talk about writing equations. And part of this is going to be review because we did this back in chapter 2. We talked about chemical equations and what they, the parts of them, reactants, products, etc. Now, prior to this, you had an assignment to look up some information in your book. So the first page of your packet actually looks like this. And I'm just going to go ahead and pull that page down. So if you were absent and you didn't get the assignment, you can go ahead and I'm just going to run through this. So you might want to pause the video and fill in your note sheet. But this is what it's kind of general introductory information. We don't really need to spend a lot of time on, but I wanted you to have it in your packet so that you could reference it. So the definition of a chemical reaction is the process by which one or more substances are changed into one or more different substances. And in chapter 2, we talked about the fact that a chemical reaction, a physical reaction is reversible. A chemical reaction, the products are not the same as the reactant. What you end with is not the same as what you started with, and that's the definition of a chemical reaction. How do you know you've had a chemical reaction? That's our indications here. You sometimes produce heat and light, or not always, and sometimes you can have heat or light and it's not a chemical reaction. So these are general rules of thumb. Sometimes you'll create a gas. Although if you think about it, if you boil water, you're creating water vapor, a gas, and that's not a chemical reaction. Formation of a precipitate is almost always a chemical reaction. It's a solid that forms from two or more aqueous solutions. Then we go into writing equations. So that's what we're going to talk about today. So equations have to have reactants and products. So you have to start with something and end with something. The formulas have to be correct. And I'm going to grab my red pen here and I'm going to star this. Because what happens is we want to forget everything we learned in the last chapter about writing formulas. And just, you know, if I see sodium carbonate, I just want to write NaCO3. Well, sodium is +1, carbonate's -2. So you have to write Na2CO3. If you don't, nothing's going to work. And the reason that we're going to look at balancing equations, and the reason for that is you have to conserve matter. Law of conservation of matter must be satisfied. And I put here, and I'm going to say this about a dozen times before we're done. When we balance, when we do what's called balancing equations, we balance with coefficients. We never change the subscripts. You guys should have balanced equations before back in your freshman year of science. So hopefully that will be reviewed for you as well. Okay, and that's just the basic intro that you guys did. You looked that up. So what I really want to talk about today are, we want to go back over writing chemical equations. It's my coffee. All right, let's get started. So I'm going to write AX plus BY gives us AY plus BX. Now, we know a little bit more at this point than we did when we first talked about chemical equations. But what we said was, these are the reactants. These react together to form these products. And 90% of our chemical reactions that we're going to look at are going to be ionic. So we're going to be doing mostly ionic. I'd say 90% are going to be ionic compounds. Right off the bat, let's make sure you guys understand that A and B represent cations, and X and Y represent anions. So in this reaction, I've taken a compound and I have a cation A and anion X, cation B, anion Y, and you can see that they've switched. So I just want to put that out right at the beginning. We talked about the fact that the arrow, so the arrow indicates the direction. Well, sure. I mean, that makes sense, right? We can only go one way. Well, that's not actually the case. Over here off to the side, we have a table of symbols, and you'll notice this double arrow. The other thing that we could do is we could have, let's do another one. So let's say this is A, X, solid. No, let's make it, yeah. So plus B, Y, liquid. I'm going to put this double arrow in. It's going to be A, Y, L plus B, X, AQ. So I added a few things here. When we have this arrow, this means it can go both directions. This goes forwards and backwards, forwards and backwards. So this, when I put this solid into this liquid, I'm going to get an aqueous, and I'm going to have this. And the other thing is I'm using terms here. I started to use those before I explained them. These are the states of matter. So S is solid, L is liquid, G is gas. So where's my G? G is gas. AQ is a solid dissolved in a liquid. So aqueous, AQ stands for aqueous, AQUEOUS, and that is a solid dissolved in a liquid. So we have a forward arrow or a split arrow, which means this reaction goes both this way and this way. We have our states of matter. What else do we have? Okay, let's look at these down here. We've got things that are written over top of the arrow. Here I have a delta sign. So this is an arrow with a delta. This has, it says 2 atmospheres above it. This says pressure, this says temperature, this has got a compound. These all represent, so something above the arrow, if you have something above your arrow, it indicates it's needed for the reaction to take place. Indicates it's needed for the reaction. So all of these. It means that in order to, for the reaction to go, you have to add pressure, or you have to add heat, or you have to add this compound. But these aren't necessarily part of the reaction. So the only other one we haven't talked about yet is this little down arrow. Up here I have, let's go with, say I've got aqueous. I've got aqueous. I'm going to have aqueous, and then I have a solid. When I combine 2 aqueous solutions and I end up with 2 new solutions, but one of them is a solid, sometimes you'll see this next to that solid. That solid, this means that this is coming out of solution and it's going to drop to the bottom of the container, and we call this a precipitate. A precipitate. And we had that definition on the last sheet, that it's a solid that forms from 2 or more aqueous solutions. Sometimes you'll see it just as a solid, sometimes you'll see it with this down arrow, but let's rewrite that definition. So a precipitate is a solid that forms from the combination of 2 or more aqueous solutions. All right, so just to recap this section, I want to make sure we've got everything. We've got our reactants and products. We've got that a reaction can go one way or it can go forwards and backwards. We have our states of matter, solid, liquid, aqueous, and gas. We talked about the fact that A and B represent cations, X and Y represent anions, and that are above the arrow conditions that might be needed for that reaction to go. So these are all things you might see in a chemical equation. So let's do a little bit of practice and review. Let's turn some word equations. It should say word equation into a formula equation. So I had a little bit of a typo there. Sorry about that. And because of space, I'm going to write above. Usually we write below, but I'm going to try to keep everything in screen. Right, so the thing we said was that you have to have correct formulas. So I'm going to have sodium oxide. So I'm going to need the formula for sodium oxide is added to water and it yields sodium hydroxide. So let's just, before we write these into a formula equation, let's write these formulas. Okay, pause the video and see if you can write the formulas for sodium oxide, water, and sodium hydroxide. All right, if you remember, sodium is +1 and oxide is -2. Here we have sodium +1, hydroxide is -1. So the formula for sodium oxide is going to be Na2O. Sodium hydroxide is going to be NaOH, and water, of course, is H2O. All right, how'd you do? Did you get them? The added means we're going to do a plus. So I'm going to take sodium oxide, Na2O. I'm going to add to that, in orange here. I'm going to add to that, I'm going to do a plus, water, H2O. Yields, so this gives me, and it doesn't tell me that it goes forwards and backwards. So 90% of the time, you're going to be using this single direction arrow. Let's see if I can make that orange. And that's going to yield sodium hydroxide. Now, you'll notice we've got a problem because on this side of the equation, I have 2 sodiums, and on this side of the equation, I only have 1. And that violates the law of conservation of matter and energy. So this is what we call an unbalanced equation. This is unbalanced. And we're going to talk in the next video about how to balance. All right, so let's do the next one's practice. What you can do is pause the video, and then on the other side, we'll see how you did. So go ahead and pause the video and see if you can write this formula equation from the word equation below. Okay, here's the answer. Now you'll notice also here, I didn't write any solid, liquid, aqueous. The word equation didn't give me anything. Let's go through formulas first. So I've got zinc oxide, I've got carbon, I've got zinc metal, and I've got carbon dioxide gas. So zinc oxide, zinc is +2, and oxide is -2. And you'll notice I'm writing out my ions. I do that to help me. Now, solid carbon, that's elemental carbon, so that's just going to be C. Zinc metal is elemental zinc, so that's going to be Zn. Carbon dioxide, now we have our first covalent compound. So I have a prefix there, and that's a tip-off that it's covalent. So when I write the formula for zinc oxide, I'm just going to be ZNO. All right, now that I have my formulas, I'm going to write my equation. So I'm going to have zinc oxide, and this tells me it's solid, so I'm going to write an S here. And solid carbon, I'm going to want an S there to indicate. So it doesn't say plus, but it just says and, but they react to produce. So that tells you that these are the reactants. So I'm going to do an arrow, and they produce zinc metal and carbon dioxide gas. Again, balance. I've got 1 oxygen here and 2 here, but we're gonna look at how to balance in the next video, and then we'll come back around and we'll balance these for practice. Okay, that gets us the basics of chemical equations, and that's all for this video. Thanks for watching.